I woke up in a new Bugatti. 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 I woke up in a new. I woke up in a new Bugatti. 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 I woke up in a. I woke up in a new Bugatti.
Oh, I was having the best dream. It seems like nice things are just attracted to me. Maybe we can explain that with Coulombs' law, but first we have to talk about ions.
There are two types of ions, cations and anions. Metals form cations. Cations have a positive charge, while nonmetals form anions, which have a negative charge. The radii of an atom increases from right to left and going down the periodic table.
Cations tend to be smaller than the original atoms. Anions tend to be bigger than the original atoms. Look at the table for some examples.
This is Coulombs' law. The F in Coulombs' law is for the attractive force between two charged objects, ions for example. The K is a proportionality constant, or the Coulombs' law constant. The Q's are for the charges of object 1 and object 2, and then the distance is on the bottom, which is squared.
Distance is inversely proportional to force. Since d is on the bottom of the equation and squared, when distance increases, force decreases dramatically.
Distance is determined by the radii of the atoms. Therefore, if a smaller ions form an ionic compound, they take more energy to separate than larger ions due to the strong ionic bond between them. Charge can also affect Coulombs' law. Charge is directly proportional to Coulombs' law. The values of charge are located in the numerator, and when there is an increase of charge, the force increases by the same factor.
Charge is usually measured in coulombs, but qualitatively it is directly related to the oxidation state of the ion. Ions with a greater magnitude of charge will have a larger attractive force with regards to the other ions.
For this demo, we are atoms with smaller radii. It's hard to pull us apart. Maybe we shouldn't have eaten all of those. Now we are ions with large radii. It's easier to pull us apart.
Water is a polar molecule, meaning that the electrons are not shared equally between the oxygen and hydrogen atoms. This results in a slightly negative oxygen portion of the atom and positive hydrogen end. Due to water's polarity, it is capable of dissolving many molecules and atoms into solution.
This represents a water molecule.
Water molecules are polar, meaning that they have a negative end and a positive end. The molecules arrange themselves so that the negative ends and the positive ends are near each other due to the attractive forces. This is sodium chloride, an ionic compound. Sodium is the blue atom and has a +1 charge. Chloride is green with a -1 charge.
Here we see sodium chloride, which was just dropped in water. As sodium chloride is dropped in water, their bonds break and they are arranged inside the water, being soluble. Sodium has a positive charge, so it aligns itself with the negative ends of the polar water.
The chloride ion has a negative charge, aligning with the positive ends of the water.
Once the sodium chloride is fully dissolved in the water, it should arrange itself something like this.
In order for a compound to be soluble in water, the ion-dipole or dipole-dipole interactions between water and the solute have to be strong enough to break apart the bonds between the atoms.
The energy released while breaking the bond has to be enough to overcome the interactions between the water molecules, allowing them to arrange themselves around and dissolving the substance. In the picture below, the one on the left is soluble because the water and the substance are mixed, while on the right, it's insoluble because the water and the substance do not mix. In summary, Coulombs' law is the attractive force, which is equal to the proportionality constant times the two charges divided by the distance squared. Size and charge affect the attractive force. As the distance between the objects increase with size, the force between the objects decrease. As charge of the objects increase, so does the attractive force.
Water is the universal solvent. The magnitude of the forces between ions in ionic compounds helps determine their solubility.
You are now experts.
Thanks for watching.
I woke up in a new Bugatti. I woke up in a new Bugatti.